Okay, now we've reached concept number 11, which is the basic successive percentage change. And this time uh, we've used the concept number 10, where there were only two values, two percentage values. It was maybe x and y or maybe x and x, but we were applying the operation on only two values. But now we have to upgrade ourselves. We have to move to a point where we can do it with three values together. Okay. So what we've learned in the past slide was x plus y plus xy upon 100 would give us the answer of two successive percentage changes. How many? Two successive percentage changes. But if I have to do three, what I can actually do here is I can pick up the answer of the two successive percentage changes and plug it in into the same formula again with the third percentage change. Answer plus z plus answer multiplied by z divided by 100. This would give me the final result. Okay, so this is one way of taking things forward. This is one way of taking things forward with successive percentages when there are three percentage values. The second way is a formula based way. Is a formula based way. And the formula based way is a little tricky, but it can only and only be used when it should only and only be used when the numbers or the figures are very tricky. When the percentage changes are very tricky, then only you may apply the formula based change. Okay, the formula based formula is x plus y plus z or z minus xy plus yx plus zx whole divided by 100 plus x, y, z or z divided by 10,000. Okay, this kind of scenario, this thing should only and only be used when I'm writing it in the bracket. When percentage change values are difficult to solve. Okay, difficult to solve, difficult to decipher. Let's assume 37%, 28%, 29%, and these things do not have a proper fractional value. They cannot be changed into, let's say, 1 by 4 or 1 by 5 very easily. So that is when formula based percentage change, successive percentage change formula kicks in. Okay, moving on to the third option. The third option has been explained here, that the final percentage or the final answer, this would depend on the initial answer. Pretty obvious. That would depend on the initial answer or the initial value. I've written answer as wrong. Multiplied by 100 plus minus x, that is the first percentage change, divided by 100, multiplied by 100 plus minus y upon 100, and multiplied by 100 plus minus z whole upon 100. Okay, so you get it. I think I'll just take you to one of the previous slides, and I believe I've made you solve it in this fashion. This assumption based thing that we did here, I'm sorry, I have to backtrack myself to the previous slide. This assumption based thing that happened here, this was based on this formula: 100 plus minus x, 100 plus minus y, 100x plus minus z. Okay, how it was involved in that manner? I just reduced it from 100 down to 25 and worked on 25. Had I worked on 100, and this is very important, the students who are watching this particular video for the first time, no matter you subscribe or not, no matter you like me or not, please go to the video which says percentage concept chapter number 10. Learn this assumption based method and apply it using 100. Apply it using 188. Okay, as I speak of 188 and you've seen this video beforehand, you would be able to understand what I'm talking about. Okay, so this is for those who watched the previous video. This is a bummer for the ones who've come here. This is a bummer for the ones who've come here for the first time. I would request you to go and watch the previous video, because in the previous video I have taught you how to talk about basic successive percentage changes when there are two variables, and successive cannot exist without having two variables or having two percentage questions. Okay, coming back to my basic successive percentage change of three values. Okay, this is the way you have to solve things, and this is the I'm so sorry. This is the way the final answer has been taught. The final answer can be achieved. Okay, I request all of you also to hydrate themselves. Okay, so this is a question which we'll be solving. We'll be employing maybe all of the three methods over here. But let me start off with the most basic and the easiest one, which is option number 3. The price of a scooter increases successively by 10%, by 5%, and by 15%. What is the total percentage increase in the price of the scooter? Okay, what is the total percentage increase in the price of the scooter? I'll use the formula. The final value is equal to the initial value multiplied by 100 plus 10% for once, 100 plus 5% for the next, and 100 plus 15% for the last time. Okay, my handwriting might feel terrible because it takes a lot of effort. It takes a lot of effort when you have to write the long ways of solving it. But you'd see a much more beautiful handwriting when I try to verbally solve this for you. Okay, we are assuming that the initial value was 100. Now we're going to multiply it. Okay, so this is 110. Okay, so 10% extra. Reduce it to the bare minimum possible. That is 11 upon 10. Initially it was 10. 10% increase would come in the numerator. Okay, the numerator would always be bigger than the denominator in cases where the percentage change is happening in a positive way. The percentage change is happening in a positive way. The percentage change is increasing the value. Okay, the bigger the numerator, the bigger the output. The bigger the denominator, the smaller the output. Okay, the bigger the numerator, the bigger the output, the bigger the denominator, the smaller the output. Okay, talking about denominator, maybe in a few successive questions, again pun intended, in a few successive questions I will help you understand why the denominator being big is a problem for us, which would give us a smaller answer. Okay, just see this. Solving it again, 105 upon 100. Okay, just put your brains to it. 105, lowest possible value, cut it by 21 and 20. Okay, this is 20 and 21. Okay, 115, again lowest possible value, 20 and 23. Okay, by what is the total percentage increase in the price of the scooter? Okay, 21s are 25s are. We are sitting at 23 multiplied by 21 multiplied by 11 multiplied by 5 whole divided by 200. Okay, now let me start solving it. 23 into 21. 21 threes are 63. 6 would be here. 21 twos are 42. 42 plus 6, 483. Why am I solving? Why am I using the bigger numbers first? I've already told you about it. I've already told you about it. The answer is, the answer is, tell me why. The answer is that bigger calculations can be done much sooner and should be done much earlier. And once they are done, you are relieved to reach the answer finally. If you see the bigger problem to be in the end, you might never reach the answer. Okay, now I am multiplying it. 11 threes are 33, then 8, 11 eights. Okay, there is a way to multiply things with 11. Use the last digit here. Use the last digit, copy it straight away. Now 3 plus 8 is 11. 1 would be here, 1 would be in the air. 8 plus 4 is 12. 1 would be 12 plus 1 would be 13, 1 in the air. Uh, 4 plus 1 would be 5. 4 plus 1 would be 5. And 4 would come here directly. 4, 5, 3, 1, 3. Is it correct? Is it correct? Let me just check it out. Okay. Let me just check it out if it is correct or not. 11 threes are 33. My answer was 4, 5, 3, 1, 3. Okay. 11 threes are 33. 11 eights are 88. 88 plus 3, 91. 9 would go ahead. 11 fours are 44. 44 plus 9 is 43. 44 plus 9 is 43. 11 fours are 44. Um, yeah, it's 4, 3, 1, 3. Maybe I'm making a small calculation mistake. I'll just try to solve it here first. 4 ones are 4, 5 ones are 5, 5 fours are 20. Let it be this. Now I am just concerned about this. 11 threes are 33, 11 eights are 88, 88 plus 3 would be 91, 9 would go in the carry, 11 fours are 44, 44 plus 9 is 53, 53. It's 5313. Okay, it's not this, it is 5313. 5313 divided by 40. I'm going to use 4 directly here. See, I am not going to ask the senior to edit out my mistake. Okay, I will not ask the senior, or I will not ask the person who is editing the video to edit out my mistake, because I want you to see that me as a teacher, me as a person, me being your mentor, I am also bound to making mistakes. And if this is the reason why tricks should not be employed in each and every question. I was trying to employ the trick. It did not work for me. I had to go the standard way. So you should learn that trick is not required. But if you still want to learn the trick is this. Because I found the mistake in my trick. The last number would come as it is. 3 plus 8 would be 11. 4 plus 8 would be 12. 12 plus 1 would be 13. 1 would be carried forward. 1 would be added with 4. That would become 5. 5313. This is how 483 is multiplied by 11. Okay. Need not use this trick every time, because somebody like me who's been taking these exams like forever now, I'm still getting confused at times. So it's better you go the longer way. It's hardly going to take you 10 seconds, but taking the correct answer in the right time is our aim. Okay, maybe a little more time, no problem, but take the correct answer. Okay, now trying to see the percentage change in the price. Okay, just a moment. Okay, 4 ones are 4, 4 threes are 12, 11, 4 twos are 8, 4 eights are 32. Okay, so the total percentage change is 32, is 132. Okay, so I need to subtract 100 from here, and the answer comes out to be 132.8, or simply 32.8. I need to subtract 100 from here because the answer is coming out to be 132, and here we've added 100 everywhere. We've added 100 everywhere. That is why the answer is coming out to be a part of 100. Of how much more by 100? So it is 132.8. So 32.8 is the final answer. Okay. I'll try to explain it one more time. The formula is final value is equal to initial value plus the increment in the first value, then another increment in the second percentage, increment through the third percentage, and this is how I've just solved it. Okay. If you have a faster method, please go ahead, please solve it, no problem. Concept 11, question number 2. If both the length and breadth of a cuboid are increased by 12%, then by how much percentage the height should be reduced so the volume of the cuboid remains the same? Okay, this is a really good question. I'm going to use it. I'm going to solve it by using two options. The first one being successive. Successive for 2. Okay. Increase is 12%, plus 12, plus 12, plus 1.44. This gives me 25.44. Now there is supposed to be a decrease. Okay. Because the height is supposed to be reduced. The height is supposed to be reduced. Now 25.44 minus x, which is the reduction in height, minus x, which is the reduction in height, minus 25.44 minus multiplied by x divided by 100, and the final outcome should be 0, so that the volume of the cuboid remains same. Okay, so the next percentage change which should happen with 25.44 should be such that the final answer comes out to be 0. Okay, so I'll help you solve it. 25.44 minus this whole equation can be solved with the help of x. Okay, so 100x would come here in minus, and you already have minus 25.44 with the coefficient of x. So I can take x common over here and easily say that now minus is also common outside, that 125.44 upon 100 is equal to 0. Now taking it on the other side, we're forgetting about the minus sign because the minus sign would automatically go away. The value of x is equal to 25. The value of 2 here is not looking good enough. The value of x here is 25.44 whole divided by 125.44 multiplied by 100 multiplied by 100. Now I have 4 options. The 4 options are pretty distinct. They have good gaps. The differences are pretty huge. There's a difference of maybe 8 here, or maybe if I consider 24 to be the correct answer, there's a gap of 10 here, there's a gap of 4 here, there's another gap of 4 here. So you can figure out the answer. Okay, I'll tell you how. If I start cancelling with 2, it's gonna take me a lifetime, or maybe it's gonna be a nightmare for so many of you if I start cancelling it down with 2. So I'm assuming that there is nothing in the decimal. You can do this provided the options are distinct and the options are far apart. Okay, if the options are very close, let's assume 20.28, 20.30, 20.95, 20.1. You cannot do this. Okay, let's assume that 25.44 is nothing but 25 only, and 125.44 is nothing but 125 only. It breaks down the question so very well for all of us. 25 ones are 25 fives are 5 ones are 5 20s are 20. So the answer is somewhat 20%. The answer is somewhat 20%. You got it? Did you get it? Okay, I'll help you understand it with the other way now. I'm again assuming the length and the breadth to be 25 initially. Okay, and now there is an increase of 12%. The 12% of 25 is an increase of 3. So 25 plus 3 is 28. 25 plus 3 is again 28. Now, this increase has to be these things are getting multiplied. So 625 is the multiplication of these two. Then in terms of 28, what is the square of 28? Okay, people who might not know the square of 28, I will give you a straight value because I also calculate the square not in the multiplicative way, but there is a beautiful trick that I use. 8 squares are 64, 2 squares are 04. Okay, 8 twos are 16, 16 twos are 32. 32. This comes out to be 8 and this is 784. Okay, now this 784 needs to be reduced in such a manner that no change in volume comes up. Now I'll have to find out the gap between 784 and 625. Okay, I'm gonna write 625 over here and gonna say minus. This is 9 and 7 minus 2 is 5 and this is gonna be 1. So 159 159 upon 625 multiplied by 100. There's some issue with the pen. Okay, multiplied by 100. 159 by 625 multiplied by 100. This would give you the answer and it would be very much close to 20%. Okay, it would be very much close to 20%. Alright, so moving on, we have concept number 12 over here. And the concept number 12 says it's a mensuration based thing and it's an area based thing. Let the length be L and the breadth be B. If length is increased by X% and B is increased by Y%, then the area is increased by X plus Y and X plus Y. We've already done it. If there is a decrease, then X plus Y minus XY. I've already done it. I've told you the way would be the minus sign would come inside and it is minus X because there is a decrease, minus Y because there is another decrease, and minus XY would turn to plus XY. Why would minus xy turn to plus xy? The reason is very simple. That two minuses, when they get multiplied, they cut each other off and they produce plus. Okay, they produce a plus sign. The length and breadth of a rectangle, the length and breadth of a rectangle are increased by 8% and 5% respectively. So by how much area would the by how much percentage will the area of the rectangle increase? I'm going to use the basic formula over here. So 8% plus 5% plus 8 multiplied by 5 upon 100. That gives me 13 plus 40 upon 10 is 0.4. The answer would be 13.4%. Okay, good enough? Understood? Moving on. If the length of rectangle is decreased by 13% and the breadth is increased by 13%, find the percentage change in its area. Again, I'm going to use the most basic formula. The length is decreased by minus 13%, and the breadth is increased by plus 13%. Okay, decrease and increase 13%. Now the plus and the minus would give it a minus sign over here, and 13 square. 13 square is 169. So 169 I'm writing here straight away. And just to not let the question pass you over, I'm also going to write 100 over here. The question bulldoze you, not to let the question bulldoze you. I'm going to write 100 over here. Okay, this is the bracket which is closing up. This is the fine line between the numerator and the denominator. The minus things cancel themselves up, and 1.69 intact with a minus sign, which shows there is a decrease in area. There is a decrease in area. Okay, I would also take up this percentage concept number 13. It's pretty cool. I'll tell you why. The concept here, what I'm talking about is the change in volume. Okay, as I've already told you in the previous slides, when we talk about area, we talk about two quantities. Two quantities. When we talk about volume, we talk about three quantities. We talk about three quantities when we talk about volume. In area, there can be length and breadth. Okay. In area, there can be length and breadth. In volume, there can be length, breadth, and height. Things might, like in terms of spheres, there you might see an r cube in the equation, r being the radius of sphere in terms of volume. In terms of cubes, you might see an a cube. Why would I even say might? You will see an a cube when you talk about the volume of cubes. You would see all the answers in centimeter cubes, meter cubes, in liters. Liters means volume. When you're filling up a bottle, we talk about volume. Okay. So I'll just help you understand how this thing works. Okay. This is a bottle and it is filled with water. Okay. Let us assume the water to be full. Let's assume that there is no space and the water is full. Okay, I'm using a bottle, and if you find the water to be a little dirty, then trust me, this is not dirty. This is electrol powder. This is an ORS. Okay, an oral rehydration solution. This is used by many people on a daily basis to for helping the water be retained in the body. Okay, this is an oral rehydration solution, so this is not plain water. So this ORS, let's assume it is full. Now, what I'm doing here is I might be like in a practical sense, I would try to push the bottle down and I would decrease the height of the bottle. Okay, I will push the bottle down and I would decrease the height of the bottle. And in this way, I have to give an answer of how it would affect the volume of the water in it, or the volume or the space which can be occupied inside the bottle. Okay, okay. Also, what the other thing what I can do is, if you see the bottle from this side, see, if you see the bottle from this side, I think this is also a decent representation. Okay, this is a flask. This might work for you. Okay, if you see it from this side, this is the center over here. Okay, this is the center over here, and this is a little dirty, but it's okay for figurative purposes and for all practical purposes. This can remain dirty. So this is the center over here, and this is the radius that we're talking about. When I talk about this is the diameter, the longest possible chord. Okay, so when I tend to increase the diameter, when I tend to increase the diameter, then this also will result in change of a volume. If I increase the diameter, the pot becomes bigger, the vessel, the glass becomes bigger, and more liquid can be added in it. When I compress, so there is a possibility that the air which is inside might become less, and the water which will come inside would not be sufficient for you to quench your thirst. Okay, so I hope you understand. I hope you've understood everything. So what I was talking about here is that the area is a two-dimensional quantity. There are two dimensions involved, one length and one breadth. Volume is a three-dimensional quantity. There are three dimensions involved. Okay, or anything that is there would be multiplied three times. So please keep this in mind. Okay, so here the original, there would be a percentage increase or a percentage decrease. That percentage increase or decrease would be found out having the initial volume, the initial volume or the original volume in the base, and having the change here. Okay, so I've explained you the entire formula pretty well. Moving down to the question directly. If the radius of a right circular cylinder is decreased by 10% and the height is increased by 10%, then the percentage increase oblique decrease in its volume is. Okay, might sound a pretty tricky. Okay, so this is the cylinder that I have over here. This is one circle, this is another circle, and I'm assuming that the circle above is equal in terms of the size is equal. Okay, this is the radius of the cylinder and this is the depth or the height of the cylinder. This is the height of the cylinder. I'm giving you a quick glance into the volume of a cylinder. Okay, I'm using the formula of volume over here. What does volume say? Volume is measured by the area of the base being a circle over here, the volume being pi r square multiplied by h multiplied by h. Okay, it's basically having a round circular disc, and stacking the height on it, and it becoming bigger. So the number of stacks of height. Okay, I'm deliberately vibrating this hand for you to know that I'm stacking. Okay, I'm stacking the height 1, height 2, height 3, height 4, height 5, height 6, height 7, height 8, height 9, height 10. It can go to the entire height. So when you have this entire height available with you and you multiply it with the flat tops means these, the flat tops over here, the flat tops, that is when you get the volume. Okay, so the volume is pi r square h. Now it's telling me that the radius has decreased by minus 10% and the height has increased by plus 20%. So what is the final change? Okay, the radius is coming twice. Okay, and the height is coming once. So we have three variables over here. The first radius, the second radius, they are same, but the first radius and the second radius, which is equal, but coming twice because it's a volume formula. The first radius and the second radius and the height. So I'm gonna solve it that way. It's minus 10 plus 10 into 10 upon 100. I'm using the same formula. Okay, minus 10 and this would be 1. So this would create minus 19%. Okay, I've already solved such a question. Now this is the answer which is coming through radius only. Okay, this answer is coming through radius only. Now I need to take into account the height. The height is in an increasing fashion. The height is in an increasing fashion, so I would use a plus sign. The plus sign of the height, let me repeat, the plus sign of the height when introduced with the knife, when collated, not introduced, when collided, you can even call collided, when collided with the radius, which is negative, it comes out to be a negative again. So plus 20 and minus 19. These two are multiplied 20 into 19 upon 100. 19 to the 38, 380. 380 upon 100 is 3.8, minus 3.8. Okay. So minus 19 plus 20 is 1%. 1% minus 3.8. 1% minus 3 point, the answer is minus 2.8%. Okay. You see how easily this all comes out to be. How easily all this comes out to be. So concept number 13, I have used a rough area extension. I thought it will be useful, but it is not useful right now. Then coming down to this question. This question is pretty good. It says the length, breadth and height of a cuboid are in the ratio 1:2:3. The length, breadth and height of the cuboid are increased by 200%, 300% and 300% respectively. Then compared to the original volume, the increase in the volume of the cuboid will be? The increase in the volume of the cuboid will be. This is the question. Okay. So here I go. Let's assume this 1 is to 2 is to 3 to be 100, 200 and 300. Or is it at all required? Because we already have huge percentages. Let it stay as 1, 2 and 3. This is a cuboid. Okay, this is a cuboid. So the volume of a cuboid is equal to length, breadth into height. So the volume here comes out to be 6 because I'm multiplying the length into breadth into height. This comes out to be 6 unit cube. This comes out to be 6 unit cube. Now I'll be focusing on the increase. The length increases by 200. 200% means twice of it was added into it. So this came down to 3. 300 means thrice of this was added into it. Thrice of this is 6. 6 plus 2 is 8. And thrice of this, 3 3s are 9. 9 plus 3, 12 was added into it. So these are the new dimensions of the cuboid. These are the old dimensions, these are the new dimensions. But the new dimensions are not in absolute quantities. The new dimensions are also in ratio. As the first one, this is the initial ratio. The first one is an initial ratio. And the second one here, this is a final ratio. Okay, so I'm gonna multiply it. The big numbers first. 12 8s are 96 and 96 threes are. Had I multiplied 96 threes are, had I multiplied 100 into 3, that would have given me 300. But 96 is 4 less than 100. So if I subtract 4 into 3 from 300, I'll get the same answer. Okay, you have to focus on me when I speak. I said I have 12 8s are 96. Now 96 times 3 is a little tricky, But if I take it in this direction, but if I take it in this direction, that 12 8s are 96 and 96 multiplied by 3, I'll do a mental calculation. 100 3s are 300 and minus 4, 4, 4, 3 times. Minus 12, it's 288. Okay, comes down to 288. Okay, now this 288 needs to be checked of what is going on. Initially, I started off with 6. Now I am sitting at 288. 6 4s are 24. I'm dividing it first. Okay, this is the initial and this is the final. 6 4s are 24. 48. 6 8s are 48. The volume has become 48 times of itself. Okay, it has become 48 times of itself. It means there is one time which is being repeated. There is one time which is being repeated. That is why this 6 is also included over here. So I will subtract that one time from here and the answer becomes 47. For the ones who did not understand this, I will try to break it down in a different manner. Okay, I will not depreciate your mind's value or your self-confidence by saying no, there is an easier way. The other way is also equally tough or the other way is also equally easy. But let me be very clear with you of what I'm talking about. Here it says compared to the original volume, the increase. This is the original one and this is the final one. Okay, if I remove the final from the initial, That would give me an increase. That would give me an increase. Please pardon my French in writing. Pardon my French means I am abusing. Okay. Pardon my French means I am abusing and I'm sorry for that. And please do not focus on the abuse that I did. When I say pardon my French in writing, okay, so this is not an idiom. Pardon my French is an idiom. Pardon my French in writing means that I'm writing really badly, so please ignore that. And I believe my voice is coming very steadily and very smoothly. It's much better than the handwriting. It will really help you solve the question. So the increase here is 288 minus 6, which becomes 282. And 282 when divided by 6, it would sharply give you 47 as the answer. Okay, it will give you 47 as the answer. So need not worry about it. I've solved concept number 13 as well. This is an extension area not required now. So we'll be moving to concept number 14 soon. Thank you.